Hello, pre-calculus students. We are doing another word problem. So I'm going to read out loud the problem, and as I'm reading, try to highlight information that you think is important. You can pause me if you need to, but make sure you can understand what is happening in the problem. So, Elena and Jeff traveled to San Diego together for summer vacation, spending their time around the pier. Jeff has noticed that the water rises and falls on the posts of the pier. He thinks the height of the water could be described as a sinusoidal function of time. Elena was snorkeling and noticed that the pier posts are slimy up to the lowest level of the tide, which was 2 feet for this particular post. Elena and Jeff investigated the tides and found out there was a low point on the post at 8 o'clock in the morning and a high point 40 inches higher at 2 o'clock in the morning. Find an equation for the height of the water relative to the post as a function of time from 12 o'clock midnight. Okay, yeah, this is a complicated problem, but it is important to be able to pinpoint important information. So pause me and make sure you've underlined important numbers in the text. And here are some things that I would have underlined or highlighted. Okay, so the lowest level is at 2 feet. The lowest point is at 2 feet. And that low point is at 8 o'clock. So all those pieces of information go together. The lowest level, 2 feet, 8 o'clock. Some other information that's useful is that the high point is 40 inches higher at 2 o'clock. Okay? So those two things, those information are going to be able to help me find 2 points. So I'm going to take that information and I'm going to draw it on this picture on the back. So here's a picture. I'm going to kind of annotate this now to show the information that I just learned. So there is a minimum value here. The lowest point we're going to call the minimum. And I know that minimum is 20. I was told it was 2 feet. 2 feet. And that is at 8 a.m. Then I know that the high point is 40 inches higher. So the high point is not at 40 inches, it's 40 inches up. And so since I have feet and inches, I want to get a common unit. So I'm going to convert this feet into inches. So now the units are the same. So that means my maximum is 40 inches higher, so 24 plus 40 is 64. So the maximum is 64, and that is at 2 p.m. All right, there's all my important information. I want to turn this into a point. So we are eventually going to be writing an equation in the form for the height over time. So our function is going to be h of t. So we are going to be finding the height over time. My height is in inches, and the time is hours since midnight, hours after midnight. Okay, so I can turn these points here into a time and a height, time and a height, and I'm going to use those points to create a graph. So the minimum point I think is a little easier. The time is 8 and the height is 24. For the maximum, a lot of people might be tempted to put 2 and 64, but if you think about it, that doesn't make sense because 2 p.m. is after 8 a.m., but just looking at the coordinate point, it looks 2 comes before 8. So we're going to have to use military time. We'll use military time, which means 2 p.m. is 14 hours after midnight. 2 p.m. is 14 hours after midnight. So those are my 2 points, and I'm going to plot them on the graph down here. Okay, those are the points that I'm plotting. On my graph, I have my variable height and time. So time always goes on the y-axis. So we're going to put time down here. And time is, again, hours after midnight. Which means my height goes over here. That's in inches. So as I'm doing this, follow along. Let's just make our points for the time. So we'll want all the way to 14. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay. We'll stop there. I could have gone a little farther, but that's okay. And then the height, because our height has these numbers 24 and 64, we're going to have to go up really high. So we don't want to go by ones. 24 and 64 are both divisible by 8. So I'm going to go by 8s. Let's see how that works out. So 8, 16, 24, 32, 40, 48, 56, 64. Yeah. And now let's plot our points. So at 8, the height is 24 inches. And then at 14, which is right here, at 14 the height is all the way at 64. That looks alright. Remember, this is not a linear function, so I'm not just going to connect the dots like that. That's not correct. This is a sinusoidal function. So I know that my graph is going to have to be wavy. It's going to be a wave. So it'll be more, since that's the minimum, it will be minimum and then up to the maximum like that. Yeah, more like that. So that's kind of part of a function. But it still doesn't look that great. So in order to make this look like a more substantial wave, we want to be able to add more points. So the way we'll do that is by following the pattern. Notice that from this minimum to the maximum is 6 hours. So we can find another minimum in another 6 hours. So at 20, the graph will be at another minimum. At 24. So the tide goes back down, goes down there again. This looks more like a graph. Now we can also go in the opposite direction, so I can go back 6 hours to 2. So that's another 6 hours. And I can plot a point over here. So at 2, there will be a maximum value again. And the graph goes up like this. Wow, doesn't that look like a great sinusoidal function now? So I'm going to highlight this wave. There's a nice wave. Whee! That's one cycle. And we'll use this cycle to write an equation. Let's write an equation of that. So our equation is going to be this form. H of t equals a times, look at that blue graph. Think in your head, does that blue highlighted graph look more like sine or cosine? Is that sine or cosine? And hopefully, because it started at a maximum value, you recognize it's cosine. And then we'll have a b, our frequency, t is the variable, h is phase shift, and k is vertical shift. Okay. So in order to find this information, let's start with our midline, our k, and our amplitude. So the midline is going to be the vertical shift that is in between our maximum, 64, and our minimum, 24. So we know that the total length between those is 40. If we know that total length is 40, then if we divide it in half, that's 20 and 20, which coincidentally is my amplitude. So the amplitude is 20, and that means that the line that's in the middle is at 24 plus 20 is 44. So the K is 44. Okay. So remember, we can divide the graph in half. So I figured out the total distance and divided it in half to get the amplitude, and then use the amplitude to find the midline. So 44 is 20 inches away from 64 and 20 inches away from 24. Cool. So we've got our A and our K figured out. The horizontal shift, we will use our starting point. So this is a cosine graph. Cosine usually starts here at a maximum point, but it has moved over to 2. And so our horizontal shift is that the graph moved by 2. I want to make sure I'm still recording. Okay. So there's the H. And then lastly, we have to figure out the period. So the period, look, we can use this yellow. The period is the length of one cycle. So this cycle, if we start at 2, half of the cycle goes to the minimum, and then to complete the cycle, we end at 14. So 6 hours and 6 hours is 12 hours. So the period is 12 hours. 12 hours. And so to calculate our B is we take 2 pi divided by the period. And we just found the period is 12. So that is pi over 2. And so everything that we need, I'm trying to color code a little bit, is on that graph. And pause if you want to figure that out, but also pause to try to put it together into the equation. So look at the information, add it to the equation before I do. There we go. This is the equation that represents the sinusoidal function of the water of the tides at low tide to high tide to low tide to high tide. And this graph would go on forever and ever and ever because the tides don't stop. Maybe if they get a lot of rain or if they have a drought, the midline would shift up or down. So if they got a heavy rain, the midline might move up to 45 inches. Or if they live in California, it is in San Diego, so if San Diego experienced a strong drought, maybe it would go down a little bit. But this idea is that it could go on forever. So this was a lot of work, and what we did was we solved this first part. We found the equation. So all that work was to find this equation. Excuse me. And what I want you to try is to answer these questions. So think about what is the height of the water at a certain time. So 11:30 is a time. And so that means we would be plugging 11:30. I'm not going to write 11.3. That doesn't make sense. 30 is half of an hour. So instead of 11.3, since 30 minutes is half an hour, that means t is 11.5. So what we are calculating here is h of 11.5 and plugging it in to figure out how high the water is at that time. And so I will let you do that on your own. So practice plugging in, and you can use a Desmos calculator to figure out the height and make sure your final answer is in inches. And then the second part asks, when will the water be over Elena's head? So Elena is 5 feet and 2 inches tall. So again, they're mixing feet and inches. Very annoying. So we would have to figure out how many inches that is. So I know a foot has 12 inches. So 5 feet is 5 times 12 is 60 inches. So being 5'2", and some of you are probably 5'2", that means you are 62 inches tall. 62 inches tall. And so you would go back to the graph and try to figure out the time that the graph is at 62. And what you can do is you can also use Desmos. So you can graph this line. This would be the line y equals 62, and you would graph our equation, and you would figure out the times that they intersect. And you just need to find one of those times. But I'm going to have you try that as well. So go to Desmos, graph our equation, graph 62, and figure out where they intersect. And that will be the answer there. Okay, so those are the main things I want you to do. You don't have to do this bottom part, but it could be helpful for you to just rewrite, basically explaining the steps that we took. So for you to show that you understand this, you will write what were the evidence in the word problem. So the evidence would be, this is the evidence in the word problem. The interpretation. So the interpretation is how we found the midline, amplitude, and frequency. So you would explain these steps down here. And then the justification is explaining how we set up those equations in parts A and B. What answers did you get? And do those answers make sense in the context of the problem? All right. This is very similar to your PBL. I hope that you were able to understand some of this. Good luck finishing the problem.